This is Activity 2, Tyler's Walk, from Lesson 11, Interpreting Graphs of Proportional Relationships. And in this problem, you're given a graph. You're told that Tyler is at an amusement park. He's walking at a steady pace, and that's going to be an important point a little bit later. The word steady means that he's not speeding up, he's not slowing down, he's going at a constant rate from the ticket booth to the bumper cars. And they give you a point on the graph, and they provide a table of information, and you're supposed to figure out what 0.00 means in this situation, what happens as Tyler walks after 1 second, and what's the constant of proportionality, just different elements of this problem. All right. So the point on the graph shows his arrival at the bumper cars. So this is elapsed time. This means the time it took him to reach each of these points from the beginning. So how much total time did it take him to get to each of these points? And in this case, how long did it take him to travel a distance of 50 meters? So the distance from the ticket booth to the bumper cars is 50 meters. It's right here. This 50 for the y coordinate is 50 meters from the ticket booth. How long did that take him? It took him 40 seconds to travel that 50 meters. Now he's traveling at a steady pace. And so that means it's a constant pace, and you need that idea to complete the table. And so it begins with traveling 50 meters in 40 seconds. So it's 40 seconds. 50 meters, so that's 50 meters per 40 seconds. From that information, you can get the distance he walks per second. You just divide by 50. You divide by 40. 50 divided by 40 will tell you how fast he walks per second. What's his rate per second? And that's going to get us to the constant of proportionality. So first of all, if 0 time has gone by, he's walked 0 meters. That's a proportional relationship. That's going to go through this point right here, the origin of the graph, which is 0, 0. After 20 seconds, he goes 25 meters. So that's 25 meters per 20 seconds. So it's y per x, or y divided by x. You factor out the 5s, you're left with 5/4. So that's 5 meters per 4 seconds. So it's y divided by x, or it's 5/4 of a meter in 1 second. Both of those, and I should spend some time talking about that pretty soon. That 5 divided by 4, in this case 5 meters per 4 seconds, is the same as 5/4 divided by 1, or 5/4 of a meter per 1 second. Those are the same values, the same relationship. All right, 30 seconds to go 37.5 meters. And you can factor out the 7.5. 5 times 7.5 is 37.5. 4 times 7.5 is 30. They chose these numbers because you can factor out 7.5. You do that, you end up with 5/4 once again. 50 meters in 40 seconds. 50 meters per 40 seconds is 5/4 of a meter per second, or 5 meters per 4 seconds. And finally, the last one is 5/4. If you divide that, change that to a decimal value, it's 1 1/4, or 1 25/100 meters per second. So it's 5/4 meters per 1 second. So Tyler has not yet left the ticket booth. So 0, 0 means he hasn't left the ticket booth yet. No time has gone by, so he's walked 0 meters. How far away from the ticket booth was Tyler after 1 second? Well, in 1 second, he was 1 1/4 meters away, or 5/4 meters away. So he's walking at 1 1/4 meters per 1 second, or 5/4 meters per 1 second. So you can draw a line through 0, 0, that's on the graph. So in 1 second, so if you plot each of those points from this table, 0, 0, 20, 25, 30, 37.5, 40, 50, and 1 5/4, each of those points are going to be on this line because this graph defines that relationship. So for every time that's elapsed in walking from the ticket booth, you've gone this related distance. So over here, this y distance, or distance from the ticket booth. So 10 seconds, you've traveled 12.5 meters. 20 seconds, you've traveled 25 meters. Notice that when this doubles, 10 to 20, the distance doubles from 12.5 to 25. So 30 seconds, you travel 37.5 meters. 40 seconds, this is the one that's plotted for you in the beginning, you've traveled 50 meters. So in each case, you've traveled at a rate of 5/4 meters per second, times 10, times 20, times 30, times 40. So this is 1 25/100 times 10 is 12.5. 1 25/100 times 20 is 25. 1 25/100 times 30 is 37.5, and so on. So these points are labeled, the x coordinate is labeled first, then the y coordinate. So this is 1 and 1 25/100, 10 and 12 and 5/10, 20 and 25, 30 and 37 and 5/10, and 40 and 50 meters. So the y coordinate is always the number of meters. The x coordinate is where you start. So you start at 0 and you go out a certain amount of time, and then go up to the graph that tells you how far you have traveled in that time. So what is the constant of proportionality in the relationship between time and distance? So the two properties are time and distance, and they are connected. They are related through this constant of proportionality. So you're walking at 1 25/100 meters in 1 second. So that's the constant of proportionality. What's your constant speed? What's the distance that you're traveling per time throughout that walk? That's always a related distance per time. So when x equals 1, y is equal to the constant of proportionality. So you always want to get the x value down to 1, and that's going to tell you what y is, and that y is going to be the constant of proportionality, because y divided by 1 is y. So 5/4 divided by 1 is 5/4. That is the constant of proportionality. It's 1 1/4 meters per 1 second. So x is 1 second. So also it's called the unit rate. So if you get to the x value as 1, that is in 1 unit what happens. So that's known as the unit rate. So in 1 unit of time, which is 1 second, Tyler has traveled 5/4 meters. So 1 1/4 meters. So that's called the unit rate. How far, what's happened in 1 unit, in this case what's happened in 1 second. And it's also called the constant of proportionality. It's the constant factor. You're multiplying every x value by the same factor, and that's that constant of proportionality.